right, today we want to talk a little bit about functions and how we use them in mathematics. So before we do that, I want to talk first about relations. And a relation is any correspondence between two sets or groups of items. So an example of that might be somebody's name and their phone number. So my name is Joanna, and over here in this other set, you have my phone number, whatever it is. And then you can also have my office number. Like this. And then you might have somebody else's name, my friend Vince, and you have his cell number. Okay? That's a relation. It's just any sort of connection between two sets. Okay? So then after we talk about relations, we want to move on. Oh, before I move on, I want to say that we have, for these different sets, this is what I would call the input parameter, and this is what I usually refer to as the output of the function or the relation. And in mathematics, a list of all the inputs is called the domain, and the outputs is called the range. Okay? So we have that kind of setup for a relation, any sort of correspondence between two sets. When we move down to functions, a function is a relation, a correspondence between two sets that assigns each input to exactly one output. So our example above was not a function because you saw my name, Joanna, being assigned to two different outputs, my cell number and my work number. So that is set up right there where my input is going to my cell and work means that this is not a function. Now, the nice things about function is that they are predictable. And this is why we work with them a lot. Whenever I know what the input is, immediately the function should do the same thing over and over again and give me the same output. So each time I put in the input, I get the same output. An example from real life of a function is my name or people's names and their height. Each person has exactly one height associated with them. So when I put Joanna in as the input parameter, the output, if we had a list of everyone's height, would be my actual height. Okay? And then likewise, my friend Vince might be in here, and his height, 6 feet, not inches. 6 feet tall. Okay? So something like that. So we like them. They're very predictable. Okay? Okay, so the last thing that I want to talk about is about notation for functions. And it's really a shorthand, and you are probably familiar with it. It looks something like this. F, open parentheses, x, close parentheses, equals x plus 3. Okay? So this is read out loud, or you'll hear me say f of x. In this case, x is the input parameter, and we also call x the independent variable. When we graph things, we usually graph y is equal to f of x, the output of the function. So always when we're talking about the variable x, that's my input parameter. F of x is an output. So this is often called the dependent variable. And it is most definitely the output of this function. Okay? So let's do a couple examples evaluating functions. So for f of x is equal to 3x plus 2, find. And we'll do part A, f of 5. So f of 5, you see 5 in the place of x here. They're holding the same spot inside this function. And that means everywhere I see x in the original, I want to plug in f of 5. So here I'll write the original again. F of x is equal to 3x plus 2. And when I go to f of 5 and plug in the 5, I plug it there, and I plug it in here. Now, a quick tip, you'll see that I plugged it in parentheses. That's always good to do when you're plugging things in, especially until you get used to this notation to make sure you don't miss anything. So 3 times 5 is 15 plus 2, that should be 17. So B, I want to find f of negative x. Same exact thing. I want to start with my original function, 3x plus 2. And now in this line, everywhere I see x, I'm going to plug in negative x in parentheses. So I get negative 3x plus 2. Simplify. So f of negative x is equal to negative 3x plus 2. Let's do one more. F of x plus h. So I'm going to start again, f of x. Oops, I want to get rid of that. F of x, start with the original, and plug in x plus h everywhere. I get 3x plus 3h plus 2. Okay, so I want to continue this problem a little bit more because soon we'll talk about something called the difference quotient. So this is a little bit of kind of pre-practice that you'll see in your homework. And so for this problem that we just did, f of x is equal to 3x plus 2, we just found f of x plus h, which is equal to 3x plus 3h plus 2, right? And so then in the difference quotient, we want to find another, so this is maybe the first or part A of a problem you'll see in your homework, f of x plus h minus f of x. Okay? In that first part A, I already found f of x, so I don't really need to find it again. I really just have these two pieces. So I have this piece, f of x plus h, that's the same as this, and I'll carry it down and it will get replaced. Then I have minus, and I actually have up here a definition of what f of x is. You see that? That says what f of x is. So I can replace that with 3x plus 2. I suggest you put this second part in parentheses because there's always a minus here, and you always have to distribute the minus sign. So 3x plus 3h plus 2, I'm just going to simplify this, minus 3x. First, just distribute this minus, and then you'll see the 3x's cancel here. They subtract, and the 2's also subtract, so I'm left with just 3h. Okay? Now, C. I want to find one more item, which is f of x plus h minus f of x all over h. I already found this numerator, right? This numerator is the same as part B, is the same as this. So I'm just going to sub in that the top is 3h, the bottom is h, and then when I cancel these h's, because there's an h here and an h here, I just get left with 3.